Lesson 28 is another two-parter, total internal reflection and prisms. And to get a good appreciation of total internal reflection, I'd like you to pause this video and go to YouTube and watch this video, fiber optic cables, how they work. It's a really good video. It's a little technical in the middle, but great description of total internal reflection and why it is important in modern society. Lots of engineering applications for fiber optic cables. So pause the video. All right, you're back. And before we go on to discuss it, I'll give you an example. Let's do total internal reflection by one of the examples you've likely been exposed to, a phenomena that you've seen, I'm sure. And total internal reflection will explain this phenomena. And this phenomena is, let's say you are driving down the road, and you are standing on top of your car because you're not terribly bright, and it is a sunny day. It doesn't even have to be a warm or a hot day. In fact, I remember driving down the road when it was minus 32 outside, and I still saw this phenomena. And the phenomena is you look down the road and you see what you think is a puddle, what appears to be a puddle of water. And as you're getting closer to that puddle disappears. Okay, so what do you think? They call it a mirage. It usually has to be a sunny day, because what's going to happen is on a sunny day, the road is made up of asphalt. And on a sunny day, the temperature of the air just above the road will be a little warmer. The sun will heat up that road, and it will be a little warmer right here. And what happens is you kind of get this invisible barrier of air that separates the warm air from the cold air. So you have warm air right above the road, and then you have cold air above it. And in terms of physics, we call this a more dense medium, and we call this a less dense medium. Just going to put it down here, less dense medium. So your light rays are going from a more, if we're going in this direction from you, down this way, they're going from a more to a less dense medium. And we know from our previous lesson that when you go from a more to a less dense medium, the light rays bend away from the normal. So let's say I take this ray here, and I'm going down there. I'll create a normal. Which way is that light ray going to bend? It's going to bend away from the normal, so more in this direction. There's my angle of incidence. There's my angle of refraction. Make sense? Nothing groundbreaking about that. But what happens if I look further down the road? If I look further down the road, let's say there, all of a sudden my angle of incidence becomes bigger. Angle of incidence becomes bigger, and then this one's going to refract even more. My angle of refraction is going to be even bigger. And you can see what's going to happen if I look even further down the road. At some point, the angle of refraction, it's going to refract so much that it's actually going to be parallel to this invisible line that I've got here. So your angle, it's going to actually refract at a 90-degree angle. So here's your angle of incidence. This angle of refraction becomes 90 degrees. And that's a special angle. That's called the critical angle. The critical angle is this value here that will make this 90 degrees. And if you look even further down the road, you can see what's going to happen, or hopefully you can see, something magical is going to happen. And at that point, the light is going to say, well, I'm done with refracting. I can't refract anymore, so I'm just going to reflect. So right here, this R here now stands for reflection. That's why it's called total internal reflection. It means just it's refracted so much that it can't refract anymore, and it's only solution is to refract. So what you're seeing, that puddle, is actually just a reflection of whatever's in front of you. It's normally the sky, but if you're driving down the road, whoopsie, driving down the road on a very funny looking car and you're just ahead at this point, you've tragic accident, you've lost your body because you were standing on top of the car on a hot sunny day and there's a mountain here, you may actually just see the reflection of the mountain. It's kind of whatever's in front of you. Usually it's the sky. So that's what you're seeing. That puddle there is just a reflection of what's in front of you way off in the distance. Okay, so I hope that explains that phenomena. You can now go over your notes. That explains it quite well. And then the important part, this is very popular on diplomas, this concept here of the critical angle. The critical angle, as I've said, is the angle of incidence that will yield an angle of refraction of 90 degrees. So in other words, what's this angle? What's this angle here, angle of incidence, that will make this angle 90 degrees. Okay, and we're going to just do, I don't think there's an example in your notes, so we're just going to make up an example right here. It says find the critical angle for a diamond. So if you've got light coming out of a diamond, what's the critical angle that will make it totally reflect and not refract? So here's how we're going to do this, solve this problem. We're going to say here's our surface. Here's inside the diamond, has an index of refraction of 4.2. Here's the air, index of refraction of 1. And what we're asking for is what angle in the diamond will make the angle of refraction into the air 90 degrees, thus creating total internal reflection. So it's going to be sine theta. Now I'm just going to, instead of putting 1, I'm just actually just writing diamond divided by sine theta air equals, and then our n values, n, air, n, diamond. Okay, and once again, if you get these confused and backwards, you're gonna get actually syntax error on your calculator, or an error. It won't be able to do it. So if you made a mistake on these values, you'll know it right away. And then I can just plug in my numbers now. What am I solving for here? I am solving for this. I'm solving for what angle in the diamond, the angle of incidence, will make this angle 90 degrees. So it's really sine theta d over sine of 90 equals 1 over 2.42. The sine of 90 is just 1, so that just becomes 1. So really just inverse sine of 1 divided by 2.42, and you're going to get an angle of, inverse sine 1 divided by 24 degrees. So in other words, this here, this is the normal here. This angle here must be 24 degrees. And that will make the angle of refraction 90 degrees. Angle of incidence, the angle of incidence that makes the angle of refraction 90 degrees. And that's a very small angle for diamonds, which is why diamonds are so sparkly, maybe. Okay, that's it. That's total internal reflection. We will now move on to prisms in part 2.